Hey, good morning, Pirates. It is February 11th. It's an A day before a 4-day weekend. Real quick video of our agenda and plan for today, which is mostly a catch-up day. After bell work, we're going to do our final section of notes over graphing. So it's called motion graphing. There is not a quiz to take over this section, so you're just going to complete your motion graphing notes. And at that time, all 5 sections should be complete, so you can submit them, and I can start grading your notes for motion. And then use Canvas grades to get caught up. There are lots of zeros, missing assignments from last week. If you would go ahead and finish those things up and get them submitted, I can get them graded and your grades will improve. Real quick discussion, a little bit more in depth on acceleration, which is today's bell work. And so today I want you to write the date on a new slide, write the equation for acceleration, and then make up a sample problem and solve it for acceleration. And in class, we're actually going to use this slideshow that has data from last week when we compared the volleyball to the basketball rolling down the hall. Here's the equation for acceleration. The formula is the acceleration can be determined by subtracting the final velocity minus the initial velocity divided by the time. So another way to look at that is the change in velocity over the change in time that occurs. And so to apply that, we're going to use our data from last week. Our speed columns will be our velocities. Our time column becomes our times. And so if we were to look at what would the acceleration of the ball be at 20 meters, so we would come down here to 20 meters, where the speed is 5.56, and it took 3.05 seconds to get there. And so the initial velocity would be 0, and the final velocity is 6.56. And we would divide that by the time of 3.05 seconds to get the acceleration. And so your work for that number 1 might look like this: 6.56 minus 0. 6.56 minus 0 divided by the time it took, which is 3.05 minus 0, or 3.05. And so you have 6.56 divided by 3.05 gives you 2.2 meters per second per second. So every second the speed is changing by 2.2 meters per second. Another example. What would the acceleration be of the ball at 35 meters? So down here at 35 meters, we have a velocity of 5.06, and it took 6.92 seconds to reach that velocity. If you start at 0, that would be your time, and 0 speed. So to solve this one, we would do 5.06 minus 0 divided by 6.92. and you would get 0.73 meters per second. So those are pretty straightforward when you have starting or initial velocities of 0 and time of 0. It gets a little more complex if we look at this third example. What would the acceleration of the ball be between the 10 and 35 meter mark? So at 10, our initial would be 5.68 meters per second, and then our final would be 5.06. And the time it took would be 6.92 seconds minus the 1.76 seconds to get our time that had elapsed. And so solving this, final velocity 5.06 minus initial velocity 5.68 divided by the time 6.92 seconds minus 1.76 seconds, it gives you a negative 0.62 meters per second, so it's slowing down, and that occurred over 5.16 seconds. And so our acceleration would be a negative 0.12 meters per second, slowing down. And again, that's an example of an acceleration that is negative, which we might also call a deceleration. Take a look at these. You might try to work some sample problems on your own. next week we'll actually start to do some practice problems as a part of our assignment for the class. Again, let me know if you have any questions. The Zoom will be open today. I hope you have a good day. Stay warm. It's super cold out, and we'll see you next week. Bye.